Hello to all. Welcome to this session on time series analysis using Python on the session 2. My name is Sukant Jain. I am working as a scientist C in National Institute of Hydrology. So, yesterday we have talked about how to play around with the time series dataset using the Pandas library, and we have also learned about various things that can be done uh, using the time series dataset, like aggregating, resampling, and slicing of time series dataset. So today we are going to talk about the gridded data. So what is actually gridded data? It is nothing but the time series stored in a structural manner is known as the gridded data format. And most of the climatic data set like temperature, rainfall, wind speed, etc. that is a very helpful in our hydrological modeling, water resource assessment, and not only that, the future climatic data, which is also very important in hydrological modeling area, are stored in the gridded format. So today we are going to talk about that, and we are going to use the Python libraries in order to extract these kind of gridded data set into our user friendly format. So what is the graded data? So graded data organizes the spatial and temporal information into a structural grid where each cell represents a specific location or time interval, and it is structured in such a manner that each cell contains some type of variable. It can be temperature, precipitation, etc., which provide a comprehensive representation of the environmental conditions. And its application is very widely acceptable throughout the world. Many type of models, or that we can say platform, utilizes this kind of data sets. So what is actually graded data? So when we talk about something station data, we just extract from a particular location. The graded data are stored in some grid format. The size of the grids depend on the resolution of that data. For an example, IMD graded data, which is a very popular in India, it stored the rainfall in 0.25 by 0.25 degree. That means approximately 25 kilometer by 25 kilometer of grid. If you zoom into an area, that grid is represented by the centroid of its latitude and longitude. And after the extraction of any particular grid, this kind of data sets can be extracted. For an example, if your gridded data stores the data set of like 10 years, so you will get 365 into 10 values to extract for a particular location. So why we are using gridded data when we have already CSV file and all the traditional formats? So the advantages of gridded data itself is that it provides improved data organization. It's have an efficient storage. It reduces the redundancy and it enhances the accessibility, making them ideal for large scale analysis. But the disadvantages is that a specialized software or a specialized skill is required to analyze these kind of data set. But after this and after the end of this training course, when you are very well versed with the Python's basics, you will be easily uh, use the Python language, Python programming language, to extract this kind of data sets. So there are different formats of grid data set. The most popularly used is the netcdf file, also known as MC file. And then we have HDF5 format, we have grid format, then we have also GeoTIFF format. So these are the different formats of grid data sets, but the storage condition or the structure of these data sets are very much similar. So there are different tools and software to extract these kind of data sets. For example, the Python, there are some Python libraries like netcdf4, xarray, h5py, which are very helpful in extracting those data sets. There are some command line tools which can be installed in your computer. So these are very Linux platform, user friendly for Linux platform. Then there are some software application which can directly be installed, but the disadvantage of these software is that they are not flexible enough to recreate the extraction procedure according to your data sets. And there are some cloud computing tools like Google Earth Engine which can be very easy to extract those data sets, but the problem is that it only helpful in those data which are already uploaded in their platforms. So today we are going to use the Python library, specifically xarray, in order to extract the data set. So in today's exercise, we are going to use the X-array. we're going to use the pandas and numpy libraries in order to extract the data from netcds file. We're going to talk about the netcds file from IMD graded dataset. We're going to talk about netcds file from NASA's future climate dataset and some other example. So in the netcds file or any graded data, the data is stored in such a manner that for each and every variable, it can have a multiple variable like precipitation, temperature, and many other variable. So for each other variable, in order to extract that particular value, we should have correct information of latitude, longitude, and reference time for which we're going to extract. So in order to use this thing, we are just going to open our Jupyter notebook. So I'm going to, this is my directory. I'm just going to open Jupyter notebook directly over here. You can open via your Anaconda command prompt. So first of all, I'm just going to open a new notebook. Going to new Python 3. Okay. So first of all, I'm going to import some libraries known as import X array, then import pandas as PD, then import numpy as np. Now, most of the user I think have already installed this pandas and numpy, and you might not be knowing about the xarray. So xarray is a library. I'm just going to open Google page of xarray and how to install that thing. So xarray makes working with a label multi-dimensional arrays in Python in very simple and efficient way. So in order to install this xarray library, the procedure is simple. How to we have installed the previous library if we have instructed you in this course. But if you're not, then it can be installed by two methods, either through pip or directly through conda. So you can just go to search for xarray installation. So it will directly give you a web page how to install in your Python environment in very easy manner. So uh, in my PC, I've not installed my Jupyter notebook through Anaconda. So in order to install, what I do, I just go for command prompt, and if my internet is working, I just use pip install xarray and hit enter. Then after certain few minutes it will be installed. So suppose if you are not using directly pim install, you can use the conda environment. So you can see that a new release of pip is already available. uh, okay, so it is saying that the requirement already satisfied. That means xarray is already installed in my computer. Okay, so if you don't want to install through pip, you can install with the condas, and the command from condas is that this one. Okay, that means conda install c conda forge xarray. Okay, or you can directly search in the Google uh, conda install xarray. So sometimes it is very difficult for some libraries to be installed. So you can directly Google that command. So it will directly give you how to install. So simply copy this line conda install anaconda xarray into your that because in my PC it doesn't have anaconda in the anaconda command prompt, and directly give this command. So it will directly install the xarray library into your computer. Okay, so after just giving these three lines, I'm importing all of these three libraries into my Python environment. I'm just going to hit run. Okay, so this symbol is saying that now my code is in progress, and that means now this symbol is off. That means my code is successfully run, and all the three libraries are into my computer, and my local Python environment has create a copy of these libraries. That means I can use this library into my code. Either you can use import X array as it is, or you can use import X array dot xr. But I'm very much friendly with this kind of full X array. Okay, so with this data set, we are going to provide you certain types of data set. So first of all, what we are going to do, so with this exercise, I'm going to use some data sets which has a format .nc. Okay, so this folder contains the 4 files of .nc format. It is provided by the IMD graded dataset. Later on this session, I'm going to tell how to download these kind of files. Okay, so I'm just going to extract these NC file uh, into the CSV format or any other user friendly format. So this is nothing but the rainfall from the IMD graded data for year 2020. Okay, so in order to open this, so this file cannot be opened in the Excel format. This can only be opened in any software which supports the NetCDF format. So I'm going to right click over this and click on copy as path, or you can directly copy the path from there. Okay, now I'm going to create a variable known as netcdf1. Okay, then x array dot open underscore dataset. This is very much similar how we open any CSV file or Excel file through pandas. Okay, here we describe the pandas, then dot read underscore CSV. For here we are going to use xarray dot open dataset and we give the path. Okay, this is the netcdf file and we are going to print this. We can print directly and hit run. So it throws an error that's Unicode except. Okay, so that means we have to convert this backslash into forward slash, or we can simply write R over here and run once again. So this is how your NetCDF data looks like in a very user-friendly format. I think you are very much familiar with the dictionaries. So this is nothing but a set of dictionaries, how the information is stored. Okay. So like in the PPT we have talked about, it can have multiple dimensions like X, Y and Z. So X may be latitude, longitude and Z may be time. So here we can see that it has 3 dimension latitude. It has the information of 135 latitudes, longitude 135, latitude 129, and time 366. That means it has a value of 366 days because it's 2020 and this is the daily data set. So it is a leap year. That's why this kind of information are stored in this particular NetCDF file. So this is about the dimension. Next is that we have talked about the variables. So when we go to the variable, it is stored. It has only one variable, that is rainfall, which are stored in the uh, three-dimension array and time, latitude, and longitude. And if you want to, see the detail of all of these arrays, you can simply just click over there so that you can see the metadata or the attributes of that coordinates. Like the latitude are stored in the degrees unit. Okay, and the longitude is also of course stored in the degrees, and the time, if you click on the time, so the time origin is 31st December 1900. Okay, later I will tell you why this is coming 13th December 1900. Okay, and if you click on the metadata of rainfall, you will find that it is stored in the name of rainfall, small capital R, then rainfall. And why it is important, I'm going to tell you afterwards. And the units are in mm. Okay, and if you click this database sign, then you will be able to visualize the array, how this longitude are stored. So these are the values of longitude that are stored in this particular array. that means longitude from 66.5 to 100, and latitude is stored, sorry, okay, from 6.5 to 38.5. And if I want to see the time, I just need to click this show and hide data representation. So now I can see that there is an array showing the time at date like 2020-0101, and time is also displayed, and you can see yesterday from the yesterday session that the type is date time index. That means we don't need to convert this data set into date time. It is already being converted into a time series data format. Okay, similarly you can click on this, so you can find that there are total this much of values stored in this particular variable. Okay, now this is the structure of the data set, and it is very important that when you use any kind of netcd file, you should be able to understand how your data sets are stored in different coordinates, dimensions and variables. Okay, so now I'm going to extract, first of all, visualize this data. So in order to do that, we can simply just use netcdf1. Okay, then in order to access all of these values in an array, because this is uh, in this netcdf file there are four type of arrays. One is longitude, one is latitude, and one is time, and one is rainfall. So in order to extract any type of array, what we are going to use, we are going to write this variable name netcdf1. This is the netcdf1. Then we're going to use the inverted commas and the variable or the dimension name which we are going to extract. For example, if I just use this longitude, and if I hit enter, so I got the array of longitude only. Then if I use only the rainfall, only the variable, copy and hit enter, so I got the array which has 637890 values. Okay, so in order to plot this three-dimensional array which cannot be easily plotted, so I need to convert this 3D array into 2D array. So I'm going to extract the data of all the latitudes and all the longitude, but for a single time frame. So for that purpose, I'm going to use this square bracket, then -1 colon, sorry, comma colon, and then use plot. Now you can see that we have plotted our rainfall uh, through the matplotlib library, which is automatically installed with xarray. So in the x-axis you can see the longitude. It is from like 65 to 100, and latitude is from 5 degree to 40 degrees, and we have a scale from how much rainfall is variable from north to south. So we can see this is the uh, data set. This is not the average data set, but rainfall value of 31st of December 2020, and we can see that in southern part of India we are receiving some amount of rainfall, because in this date there are very least chance to have a rainfall in central or middle part of India. Okay, now you can see that we have used three things: -1, then colon, then colon. Okay, so you can see that the variable rainfall is stored in a 3D array, three-dimension array. The first dimension is time, second dimension is latitude, and third dimension is longitude. So by using this -1 in the first place, we are extracting the last time of this array. So last time means the last date of this particular array, that means 31st of December. And when we are not using anything but use the colon, so that means we are going to extract the data set from all the latitude, and similarly we are using not any values but a colon. That means we are going to extract the all the values of this particular longitude. Okay, now if I just need to extract the value of any particular lat and long in any particular date. So how do we do that? We just going to use first of all any date that are maybe in some time of June, July or August. So maybe 200, and let's see the plot. So we can see that central or northern part of India is receiving some amount of rainfall because this date is 19th of July. Okay. Now, if I want to extract the value of any particular latitude or any particular longitude, suppose if I just give 40 of latitude, let's see, we are getting the data set into a bar graph because this is not a three-dimensional array. This is a 2D array in which we are getting longitude, a multiple longitude, and the rainfall in a mm. And if we give a value over here like maybe 50, now let's see. So no numerical data to plot. It may be that it may be because it is only a 1D array. So now if we remove the plot, we get the value of only one, which is zero actually, because it may be possible at that latitude and longitude and time the zero rainfall is occurring. So this is how our data sets are stored in a structural manner in NetCDF format. Now our task is to extract the data set of any desired latitude and longitude. Okay, so for that purpose we are going to store all these 3-4 arrays into a separate variables. Okay, so for example, we are going to extract the array of latitude first, and for that we are going to use netcdf 1, then square bracket, then in the inverted commas we are going to provide, I'm just going to hit first of all enter, we are going to provide the latitude. Please make sure the spelling of this latitude and the case sensitiveness of this latitude should be same when we provide over here. Then we are going to extract the LON, area of longitude, and let's see the longitude name, just copy, sorry, we are going to paste over here. Okay, and array time. Okay, now, oh sorry, this is the capital time and the capitals. Now if we see type of this uh, array, so this is the X array data array, so we need to convert into a numpy array. So for that purpose we just need to use the command np dot array and use this in this particular section. So when you are very beginner Python, when you are very learning Python base by base, you can do in separate lines, like first we create a variable and store the X array, then we stored another variable like array lat1 and np dot array, and in that np dot array we are going to use X array. Okay, either you can use this. Now you can see that the latitudes are stored in a very easy format that can be easily understand or extracted by some other numerical functions in the Python, but I'm going to use this np array in the same line, so it will reduce our code length. And similarly I'm going to use this in all other variable extraction, and we are going to extract the variable array. Okay, rainfall. Okay, for this rainfall I'm not converting it into numpy array, because it can be easily extracted from this array also, and it is very easy to plot afterwards in this array, but it is not easy to plot into the numpy array. So I'm going to leave it as it is. Okay, and now I'm going to plot this variable array dot plot. Okay, so what we have done, we have extracted all the arrays into our required format. Next thing, we are need to extract the data set for any given latitude and longitude. So suppose we are going to extract the values maybe for Delhi region. Okay, so for Delhi we have a, you know, latitude. We need to get the latitude. I think it is Delhi lat long in decimal places. It's 28.65 and 77.23. User lat is equal to 28.67, I think. User LON 77.23. Okay, so we need to extract the 365 values of this particular latitude and longitude. Okay, now let's see into our original array where this 26.67 have an index. So if we go to the latitude, okay, so the nearby to 26.6, I always forward 26.67. Okay, so we can sorry, so we can clearly see that 26.67 is nearby to this particular latitude. Okay, and this latitude is stored. So we need to find the position of this latitude. So it is stored in, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 80, 81, and 82. So it is stored, I think, in 81 position. Let's see. So I'm just going to use array lat 81st element. So this particular value is stored in position number 81 in the latitude. Okay, now similarly we are going to extract the index of this longitude, the nearby longitude 77.23. So if you go to the longitude, the 77.23 is nearby to the okay, this particular longitude 77.25, and this is stored in the index 1 2 3 4 5 6 7 8 9 2 3 4 5 9 5 45 44. Let's see. ARLON 44. So it's 77.5. I think it's 43. Okay, so we got the position of the latitude and longitude which are the closest to the user provided latitude and longitude. Okay, so in order to extract of the data set of this, what we are going to do, just going to use this variable array. Okay, and we are going to provide first of all we are going to extract we are going to provide the information for the time array. So we are going to extract for all the 365 days. That's why we are going to use colon, and then the I think the second one is latitude. So the latitude position is 81 and the longitude position is 43. Okay, and we are going to first of all extract this. So we get the value of 365 array, and this is the X array data, and we are going to convert this thing into the NumPy array. So we are going to use the array location, suppose np.array, and let's see the result. So this is the 365 values of rainfall occurring over Delhi in the year of 2000 and I think 2020. Okay, but this extraction is not a very user friendly format, of course. So we are going to store this data set into a pandas data frame. So for that purpose, we are going to create a data frame. Okay, then pd dot if you remember how then we can create the pandas data frame, pd dot data frame with a capital D and I think capital F. Okay, then we are going to provide two things, that is the array location. We can provide directly, I think, with this index format. Okay, then the index. So as you recall the previous exercise, in the previous day we have used the index as the date and time array. Okay, so here the time array is stored as array time. Okay, so we are going to use index as array time, and let's see the result. So now we can see that our data has been extracted in a very user friendly format. In the index we got the dates, and in the another column we got the values of rainfall. And if we see the df d types, so because this is the, I think, okay, so what we can do, so this is had nothing name, that means it is 0. So we can provide the name over here also, like in the form of dictionary. Like in the curly brackets we can provide rain, then colon, then array lock, then curly bracket close, then index column. Now let's see. So this is the data that we got. So in order to see that this data set is in the date and time index, so what we can use, we can usually just simply see the resample like we have done in the previous session. We're going to resample for the month wise using the sum, and let's see. Oh, the spelling of resample is mistake. So now we can see that we have only 12 values. So we can easily see that in the month of August we have received 270 mm of rainfall, and in the month of January we have received 16, and usually in the February we receive no rainfall, that's why 0. Okay, so this is a very easy manner to extract the data set, but the problem in this extraction is that we need to find the index by manually visualize and by manually locating. Now what if you can write an algorithm or write a Python code so that it will automatically extract the position of your desired latitude and longitude, and it will automatically give you the result. Okay, so for that you need to define the algorithm into your mind first of all mathematically, and then you have to execute that mathematics into the Python code. And this is how any programming language is a very important, because any programming language is just a set of code or instruction you give to your computer, but it is up to the user how you give the instructions to your computer. Okay, now your task is to automatically identify this index, that means 81 and 43, and how you will do that. So in order to explain this, I'm going to open an Excel sheet. Okay, so suppose you have a latitude and longitude, suppose latitude of 22.0, 22.25, 22.50 and 22.75 and so on. So these are the latitude with a gap of 0.25 degrees. Okay, and okay, sorry, something 23, 25. Okay, now you need to find the latitude that are closest with any user given, like 24.578. Okay, so you need to find, okay, what we can do, we can simply use this one, the Delhi latitude. Okay, 26.67. For that purpose we need to elongate our data. Okay, so we need to find the, okay, also we need to create an index. So in Python we know that the index is created by 0, 1, 2. Okay, so we need to first of all find the closest latitude from this list of from the closest from this value, and we need to find the index of that particular closest latitude. Okay, so in order to do that, what we will do, first of all we just need to find the closest, and how do we find it? If you think mathematically, there are two ways, or it can be multiple ways. So one way I'm going to apply it is that I'm going to find the absolute difference between this value and this value. And why I'm saying absolute, not the actual value, because sometimes this latitude minus may be in negative format. Why? Because the east part of the world, that means the USA, Europe, have a latitude in the negative format. Okay, so I'm just going to use absolute function in the Excel and use this 22 minus 26.67, and this thing has to be in dollars, I think, sorry. And okay, I'm just going to drag this, and let's see the formula is applied successfully. And with this value, where we found the minimum values, so we can find the minimum values as 0.08. So automatically we can see that 26.675 is the closest latitude with this particular value. Okay, and what is the index of this latitude is 19. Okay, now we need to do this in the Python. Now let's try this thing with the Python, and if you try this thing on your own, you will be now very, become very much familiar with the basics functionality of Python, because all the things that you have studied till now, that means array, indexing, numpy, pandas, and basic mathematical functions, you can do this exercise on your own also. You just need to think how do you apply this thing into the Python. Okay, so first of all what we need to do, I just create another cell. Okay, so first of all we need to find, okay, closest, let's say the closest index or what. So first we need to just we need to do this exercise, that means user latitude minus the array. Okay, so array underscore lat minus user lat, and let's see what's the result. So this is also an array. Okay, the smallest value is the 0.08. If you find the smallest, this will become the smallest. That's why we use the absolute. So for that purpose, in the numpy we have a function known as npabs. Now let's see the result. Now we can see the minimum value is this 0.08. Okay, now we need to extract the index of this, that means position, and the position is like this is 0, 1, 2, 3, 4, 5, 6, what we have done manually. So for that purpose, numpy has a function known as np dot arg minimum. Okay. Okay, so what will this arg minimum will do? You can search this into search bar of internet. So numpy.arg minimum is a method return the indices of the minimum element of the array. Okay, so in our case, this is the minimum element of the array, and we need to find the indices, that means the position of this array. So if I click this one, so this is become 81. That means the position of the minimum value, the closest latitude is 81, what we have find manually. Okay, so this is similarly we can get the, I just write closest index of lat. So similarly we can extract the closest index of longitude also, LON. Here we use LON, and also here LON, and let's see the closest index of longitude. It's 43. It's same the what we have extracted manually. Now you can see that what we have done previously by manually counting can easily be done by just one line of code. Okay. Now, in order to check that we have extracted the correct latitude and longitude, because sometimes what happen that your data is only up to like 95 longitude, and you are going to extract the longitude of like 105 or maybe 205, or sorry, not 205 but 105. So it will automatically find the closest longitude at this one. So you may not be able to get that, yes, this is the closest one, but still this is the very far away. So for that purpose, we are going to extract the latitude, the actual latitude and longitude also. So for that, I'm going to find the closest lat, and I think most of the you participants are able to extract this information. And how? Simply we use the array of latitude, and we got the index. We're going to use that index. Simple. And similarly we are going to use extract the closest longitude, array long, and closest index long, and let's see the result. So this is 26.75. Yes, it is the closest one, and closest long is 77.25. Yes, this is the closest one. Now, why I'm saying that this is also very important to visualize this information, because sometimes might be like you want to extract for Myanmar region, and Myanmar region has a longitude like more than 105. So if user provide a 105.5, so it will always give you the result, but it will show that the closest longitude is, okay, sorry, we have to run first of all this. So you can see that data has been extracted. Okay, but if you say this information, you can see that you have provided 105, but the longitude which you are getting is 100, which is a very far away. So that is why it is important to understand this concept and visualize each and every information which may be useful in your further codes. So now in the next, we have extracted the latitude and longitude and the position. Now it's very easy for you to create an automation code which will extract the value automatically. I'm just going to use this particular line, array log. Here we are going to use colon because we want to extract all the 365 values, and the first thing is, I think it has to be make sure that what are the position of that variable. First it's time, then latitude, and then longitude. So that's why we are going to provide first time, all the time, then latitude index and longitude index. Okay. Now simply we can convert this into our data frame. So your data frame will be array log which we have extracted for this particular, and the index will be the array time which we have extracted from the time array. And I think this is all enough. Yes, we have extracted the data, but now it is written rain. We can change to the provided user let long. So for that purpose, we can create another variable name in this which we are going to store the name of the latitude and longitude, which will be act as the column heading. So str closest LAN plus, I think you have already learned about string concentration. um, it can be done in multiple ways by using f string, or the simple thing which I found is this plus sign. Okay, then we used comma underscore, sorry, plus string closest long, and we're going to replace this name with this way. Okay, now hit enter. Sorry, something. Okay, now we sorry, this is should not be the name, should be like this. So now we can see that we have extracted, and the name of the column is nothing but the name of the latitude and longitude for the closest one. And this is how your data set is going to be visualized. If you recall the slide which I've shown you, so this latitude is longitude is nothing but the centroid of that particular grid, and this is the address of this particular grid. Okay, now if you need to extract, I just use this user latitude and longitude over here. Now you have written a code to extract the data set from the IMD data just by providing latitude and longitude. So this is the data set of like only Delhi. If you want to extract data set for any other city, for example Bhopal, so I'm going to first of all find the latitude and longitude of Bhopal. It's 23.25 and 77.40. I forgot 77.40. Okay, now hit enter, and we have to do nothing else. Now we can see that the closest latitude that it said fine is the exactly 23. Okay, we don't use 23 point but 23.21. Okay, so the closest latitude that it has find from 23.21 is 23.25, and from 77.40 is 77.5. Okay, so this is the rainfall of Bhopal city. So this is how you can extract the data set of your location. Okay, and if you write this set of code in a multiple loop format, so you can extract the data set for multiple location into a timely manner. Okay, now this is about the one data set. So suppose if we have a data set, okay, uh, if we have a multiple data set, for example, for this exercise, we have downloaded the IMD net CDF file for 4 years. That means 2020, 21, 22, and 23. So how do we do the analysis for this data? So there are two methods. So there is a function known as glob in the Python. So what it does, we can just first of all simply search. So glob is a Python module which helps in reading the files, reading all the files from a particular path. So for example, we have a multiple files in this particular path like 4 netcdf, so we need to use the glob function to extract the values. But the advantage of this xarray library is that we don't need to use some external library. We can simply use the function known as, I just write in the next line, net cdf all, then x array dot open underscore mf data set. Okay, so what it will do, it will open all the data sets that are in that particular folder. So for that purpose we need to provide the folder. So the folder path we are going to copy like this. Okay, we are going to, okay, we are using R over here so that we don't need to convert this backslash from the forward slash. Now we need to extract only the data set which has .nz in their extension. Okay, because it may be possible that you have multiple Excel file or some other files which you would do not want to extract. So for that purpose we are going to use extract mark. Okay, so you're going to use the plus sign, then this one, the backslash, then asterisk sign, also known as wildcard in the form of Python dot nc. So what it will do, it will first read the path, then it will read the all the files that end with not dot nc. And let's see the result. First of all, it will work or not, I don't know. Okay, yes, it's work. So initially you can see that there are in the time variable there are only 366 values. Now it has 1461 values because it has read all the data set into the folder. That means all the four data sets. Okay, in order to visualize this thing, you can see the um, time array that it has started from 21st of January from to 31st of December 2023. And if you click over this, so you can see that four different type of array have been combined, and this that you can see that four chunks in 9 graph layer have been combined, and this type of your data should look like that. It has 133.5 latitude, 129 longitudes, and 14061 time. Okay, now you don't need to convert anything else, just you have to make sure that the latitude, longitude, and time and variable name should be as it is, like, okay. Then you have to need hit run. So this time, okay, so here it is netcdf1. I'll just change as netcdf1 so that I don't need to change code all over again and again. I'll just hide this line and hit enter once again, then hit enter. I can see that the last date is 31st of December 23 because it has read all the data set. Now I just need to extract the data not only for 1 year but for all the 4 years for Bhopal city. I just hit run. You can see that there are 1461, and you can resample this line like for the monthly data, maybe resample m dot sum monthly data. Okay, sorry. And you can plot this if you want. Now you can simply see that in the Bhopal city in the month of 2000, in the month of July 2023 and 2001, we received 700 mm of rainfall, which is very huge for central India. And we can see all this by combining y, and we can use this plot as a bar plot. Kind is equal to bar. So yes, in the month of in the year 2022, we received the rainfall of approximately 2000 mm, which is a very high, more than normal. And in the year 2020, we received approximately 1400 mm rainfall. Okay, so this kind of analysis can be done using this X-array library, and you don't need to write the code again and again. You just need to provide the path, and you just need to extract the data. But there are very few things that should be keep into mind in order to play with different type of X-array dataset. For example, we just now use the IMD created dataset. Now let's take an example of CDS. So CDS is the Copernicus website data, and it is an data set for like think past 20 or maybe 30 years, I don't know. But for this purpose, I'm going to use the data set of only 2 years. So in order to extract I just need to change the folder CDS data. Okay, and everything has to be remain as it is. And let's see, now you can see that initially we have 135, 129 and 1461. Now we can see that this particular data set have the time of 17,520, which is a very high for 2 years. Then latitude of 133 and longitude was 125. You can cross check with this like for which region the data set should is belonged. So you can run this line. Okay, so it throws an error. So you should not be worried when you're working with any Python code and it throws the error. You should understand that what the error might, what is the cause of this error. So it is the key error, that means no variable name latitude is there, and the variable on the data set include TP, longitude and latitude. In the first example, I've told you that we need to copy the exact name of the dimension and the variable. Okay, so in this case, the longitude are stored in this small form, like mean not in the uppercase but in the small case. So I just need to change this latitude also, time also. Okay, and in this case the variable is stored in the TP, not in the rainfall, not RAIN, not RAIN FALL, but just TP. So I'm going to convert this TP and let's see. So this is the data set from 65-degree latitude to 100 and longitude from 5 degree, sorry, latitude from 5 degree to 40 and longitude from 65 to 100. And these are the value for 31st of December, 23rd p.m. That means at 11 p.m. And if you just see the time array information, so you can see that there are 1400 and sorry 17,520 values, and you can see that it is start from 1st of January 2002. The second value is also 1st of January 2002, but 1 p.m. or 1 a.m. So that means it is not a daily data, but it is an hourly data set. Okay, so that's why the time is very huge when we are looking only for 2 years of data. And if you want to extract the data, you just need to hit run on this case, because it has a very huge data set. That's why it may take more time than the usual. Now the closest latitude and longitude it has find is 68 and 38. So the closest latitude is at find is 68 and 38, but it should not find like that. So there is something mistake that we are doing. Let's see that the latitude it is ranging from 38 to 5 and it is catching the first one, and the longitude it's catching from 68 to 99, it is catching the one. So you can see that our code doesn't throw any error, but we can clearly see that our data set is not correct. That's why it is important to recheck your code and what you have done mistake. So let's think from the beginning. So first of all, we change the latitude. Okay. So the mistake that we have done is that instead of a latitude, we have provided the longitude. So we just need to convert this one, and here we need to provide the longitude. So what it was doing that it is searching 26.67 from the array of longitude, and if you search for 26 in this array, the closest we will find at 68, and it is searching the longitude 77.23 from the array of latitude. That's why if you search from 77 in this array, you will find the closest one is 38. So you can see that Python doesn't throw any error. It is running and efficiently, it gives the value, but it is up to the user to recheck their process. So let me hit run one again. Okay, run. then this line 1. Okay, now it has extracted 23.25 and 77.5. Very well. And now you can see that most of the values are like 0, 0, 0. It may be possible because of the uh, rainfall in this session in very less, and it is also displaying the -3, which is not possible, but it is minus 0.00000003. So let me check the unit. So if you click on this, so the unit of this rainfall is M, and that means a very high unit. So you need to convert into mm. So either you can use this by you can do this by multiplying this particular array by 1000, or simply you can extract this data set into your Excel file, and then afterwards you can do that. It is up to the user how do they want to do this. Okay, now in order to explain the different type of data sets, I'm going to explain this thing with another data set, which is a very future event data. Not, I don't know exactly, but it is a data provided from one of our previous from one of our students from our previous class, because there are a number of type of data sets for netcdf format, and the structure might be different from one thing to another thing. So it is up to the user to provide us different kind of data set if they are getting some unusual error. So I'm just going to first of all read this line, copy this path, okay, and paste it as a netcdf1 once again, because this is the single data. That's why we are using the OpenMF. Okay, now let's see. So throws an error while opening the data, and the error is value error. Failed to decode variable time, unable to decode times in units months since 2006. Okay, try opening your data set with a decode time false. So this error also suggests that how you can overcome this error. Just use this decode times is equal to false while opening this data set. So I'm just going to use this, and let's see. Okay, so now this data set is open, and there is a problem with the time, and let's see what is the problem. If that when we use this decode time, so the time array which it produce doesn't have the date and time index. It will produce the data set into a numeric format. Okay, so no problem, you can just go along with this, and you can afterward converts, was simply you just need to if you see the latitude and longitude of this area, I think this is for whole world. Okay, let's just see. So this is the coordinates of LON. So we just need to convert this LON. Then latitude is LAT, and time is time, and data set is precip, and the unit is in the, I think, kilogram per centimeter. That means mm per second. And let's see, it enter. So this data set is for like whole world from minus 180 degree to positive 180 degree. Okay. So in order to extract, just hit this line. So it has automatically extract for the closest lat long, and because this data set doesn't have a time encoded in this format, so you get the array, but you doesn't get any date and time index. So you can create a date and time index that we have done previously, like if you know the first latitude and longitude, you can simply create. I'm not going to write the full code, but what we have done on the previous date is that date pd dot date underscore range. Okay, and you can provide the start date something something and then end date something something and that frequency. So how you will came to know that what is that something something which I'm so either it can be denoted in the file name that this data set is from 256 to 265 and this is the monthly data. Okay, or what you can do, you can simply count this particular values from 2006 of January. So that means from 2006 of January, after 600 months, the first month that it comes is the 256 January. So this thing can be done in the Python, but you need to have some advanced Python skill to do that, or you can just extract the data and do the date time index afterwards. Okay, so this is the very basic code of extracting the net CDF file into the CSV format, plotting in the graphical and map manner. And in order to do something, automation for whole of your area. For example, if you want to extract the data set of many multiple latitudes and longitude, you can simply go to my GitHub account. If you simply go to github.com Sukant Jain, you can find many code repository that I've created for my hydrology and water resource purpose. So this is the code you can find net CDF to CSV. I will provide the link of this code into my Python notebook that I'm going to provide it to you. So this is the code that is written in such a manner that user just need to provide the folder path for which he or she needs to extract the data, and they just need to provide the variable name, and it will automatically create the data frame of latitude and longitude for each it want to extract. And not only that, if you want to extract all the data set from a particular latitude and longitude bounds, that means from all the latitude longitude that lie between the 35, 30, 18, 73. So you just need to run the code and it will create the data frame of all the latitude longitude. Okay, so for this purpose you just need to have an understanding how the functions work, and I think in the previous session we have understand that. If not, then you can work along with the basic code that we have provided you just now, and you can have a play around with some advanced codes. Okay, so now I'm going to tell you how to download these native CDF files from different data sources. So first of all, in our exercise we have used the IMD data. Okay, so you just simply can search for IMD graded rainfall data. Okay, if you click on first search result, you can find the graded rainfall data of 0.25 into 0.25 into net CDF format. Okay, so this is the information about the data. You just select the year, suppose 2022, click on download. It will download, then you can click one by one and download the data from 1901 to 2023. Okay, now if you want to download all of these data set into a one go, you can use the library known as imdlib, and the code to do that is also into my GitHub repository. If you go to this imdlib, okay, so this script actually use the library imdlib. You need to install this library first, and it will automatically download the net CDF file from the IMD website, and it will automatically extract the data set from your desired latitude and longitude. Okay, and it also have a facility that I have written in this code which requires some advanced Python knowledge, that user may provide a shape file or the GeoJSON file of their catchment area or any boundary, and it will extract all the latitude the data set of all the latitude and longitude that are falling in that particular boundary. Okay, so next data that we are going to talk about the future climate data. Okay, so there is a website known as NASA next uh, future data. You can simply search for that. Okay, if you search open this line, I think I've come to the wrong place. I just used to need to use the Google. Okay, NASA future climate data, SSP. I'm going to open this line, next GDP. So this is the future climate data set as per different scenarios. Okay, so there are two links. You can open either of this link. So I'm going to use this second one. So these are the different climatic models which produce the future climate data, and NASA indicates that they have uploaded the bias corrected data, and all the data sets are in the NetCDF format. So there are different models from different countries. So this is the model from the IITM organization in India. Okay, so there are five sets of data set. So there are different scenarios, SSP 126 to SSP 585. So this is a very useful data set for all the user who want to work on the future climate scenarios. That means you want to extract the hydrology for future years. So you can use this data set. So suppose I'm just going to open this SSP 370, this folder. So there are different variables. I'm going to use this PR, that means precipitation. So you can find the data set from 2015 in NetCDF format to 2098. Okay. So if you just need to download, you can just directly click and click on NetCDF subset, or you can click on HTTP server. So it will automatically download, and you can play with this file into the code that you have learned today. So I think you are getting familiar with the basics of Python, and you're now after practicing this code, you will be able to extract the data set from NetCDF file. And if you are able to do that, so that means you have uplifted yourself in the Python, because it is very difficult for many users to extract the data from NetCDF file. Uh, so, congratulations that you have uplifted your skills to Python into another level. Hope you will learn this, continue with this exercise in the future your work. And if you found any error, you can simply write to my email. This is sukan.nih@gov.in. Okay. So that's it for the day. Hope you enjoy this session. Thank you.